Okay, parathyroid glands. We'll do this and adrenal glands together. I think I can get them on one part. There's 4 tiny parathyroids that are located on the back of the thyroid. That's why they're called parathyroid. So tightly packed secretory cells, again, they're going to secrete something covered by a very thin capsule of connective tissue. So parathyroid on the thyroid, they're on the back, they're 4, they're small. Here you can see the picture. They're just almost like little circles on the back. So when you look at your diagrams that you label, the thyroid is the largest. Parathyroid are just tiny little glands that sit on your thyroid. So the main hormone is the parathyroid hormone, PTH. It increases blood calcium, so here again related with calcium. Blood calcium concentration, it decreases phosphate concentration. It stimulates bone resorption of osteoclasts. So here again, your thyroid is very important for your bones. Keeping the calcium in your bones so they don't become brittle. Those osteoclasts, preventing them from getting out of control. And that's going to release some calcium into the blood. It's going to regulate your amounts of calcium between your blood and your bones, basically. PTH also influences your kidneys to conserve calcium when needed. And that calcium then would stay in your blood. It causes an absorption of calcium in the intestines. And negative feedback mechanism. Here again, it's regulated by measuring the amount of blood calcium. So if I have too much blood calcium, it's going to lower my PTH. If I don't have enough, it's going to affect your levels. So it measures the level of calcium in your blood, and then you can see. So here's an example of the negative feedback. Decreased blood calcium. So here comes the PTH. It's going to cause kidneys to conserve calcium. Calcium is going to go back into the bloodstream. And then once I've increased my calcium, it's going to slow down that release of PTH. I won't need to conserve as much calcium. Calcitonin from your thyroid and PTH from your thyroid exert opposite effects on your calcium levels. Disorders in the parathyroid basically just deals with blood calcium. This time it doesn't involve metabolism. So hypoparathyroidism, you're going to have low levels of blood calcium. Hyperparathyroidism, you're going to have higher levels of blood calcium. That's not probably as common as your thyroid disorders. And then moving on, adrenal glands, adrenaline. I know everyone's heard of adrenaline rush. So the adrenal glands sit on top of each kidney. So you have 2 adrenal glands. And here again, they're enclosed in connective tissue along with some fat. So it's also protected by fat tissue. Kind of pyramid shaped. We'll look at the diagram of it. They do have an inner adrenal medulla and an outer adrenal cortex. So there's kind of 2 layers to each one. The adrenal medulla, which is on the inner layer, is made up of postganglionic neurons, and they are connected to your sympathetic nervous system. So it's going to be directly affected by your nervous system. The adrenal cortex on the outside is the larger portion. It's the larger portion of the adrenal gland, and it's made up more of epithelial cells, not nervous cells. And they have 3 layers of the cortex: outer glomerulosa, is the outside part. Middle, fasciculata, and inner reticularis zone. Those, you don't have to, you should know the two. There's an inner medulla and an outer cortex, but you don't need to know the layers of the cortex. So if I look at this diagram, here's the medulla, notice how small that is. Here's the cortex. So the outside cortex is huge compared to the inside part. This is made up more of your nervous or neurons. This is made up more of epithelials. Hormones, epinephrine and norepinephrine. You've probably heard those words before. So adrenal medulla is going to put that into your bloodstream. So this is coming from the inside part. The effects of these hormones resemble those of the sympathetic division neurotransmitters, except that they last a lot longer. So here, when it's secreted as a hormone, instead of directly through your nervous system, it lasts a lot longer. And this is when you think of adrenaline, these are the secretions that you think of as adrenaline, that give you that rush. They're used in times of stress, or they're called fight or flight. When you hear of an accident and someone can pick up a car, or they have this sudden burst of speed or strength, these are the hormones that cause that to happen. Release of medullary hormones is regulated by the nervous system, basically, is what I want you to know. So nervous system regulates the medulla, the inside part. That's your fight or flight, and epinephrine and norepinephrine are the main ones. So what I can see on this table is what happens. My heart rate, it's going to cause your heart rate to increase. Both of these will. Blood vessels, epinephrine is going to cause it to dilate. Norepinephrine is going to cause them to constrict. Blood pressure, basically both of them are going to cause an increase in blood pressure. Airways, going to cause a dilation from both of them. Reticular formation of the brainstem, it's going to activate norepinephrine, not so much. Metabolic rate, both of them are going to increase. So basically, it's a surge that goes into your body that increases pretty much everything. Blood pressure goes up, heart rate goes up, your airways are dilated. Your blood vessels are more dilated than they are constricted. So now, if I look at the cortex, the cells of the cortex produce over 30 different steroids. So that large outer part is very important for producing types of steroids. Some are vital to survival, typical to survival, and aldosterone, I told you this would be a big one on your test. Cortisol, which deals with corticosteroids, and sex hormones, which are important for different genders. So aldosterone, one of your big ones. Mineral corticoid, so it's mineral based is kind of the way I would look at that. It's secreted by the outer cells. Its job, its function, it causes the kidneys to conserve sodium ions and water. And then it's going to excrete potassium. So in your body, for your nervous system, your muscular system, it's called a sodium-potassium pump. So these sodium ions and potassium ions move back and forth quite often. So aldosterone is going to conserve sodium, conserve water. Potassium is going to be released. It is secreted in response to the amount of blood volume that you have and your blood pressure. And this is typically picked up by your kidney. So people who have high blood pressure Their aldosterone is probably not working properly. Cortisol, gluco, more of a sugar, glucocorticoid is produced by cells in the middle layer of that cortex. It influences the metabolism of sugar. So the breakdown of sugar, protein, and fat, stress, it's sometimes related to things with stress, and it's going to go into effect when you need a greater supply of energy. So exercise, when you're exercising, your cortisol levels will fluctuate. It's going to inhibit protein synthesis, so it's going to keep amino acids in my blood. And it's going to promote fatty acid to be released from adipose tissue, which is a good thing. I want it to come out of my storage and into my bloodstream so that it can be used as energy. Still talking about cortisol. Stimulates liver cells to make glucose from non-carbohydrates. It's going to increase your blood glucose level. Negative feedback mechanism involving CRH from the hypothalamus, ACTH from the pituitary. We talked about those a couple days ago. And the pituitary is going to control the release of that cortisol. Stress, injury, disease can trigger the release of cortisol. So thinking of blood pressure and blood water content, blood volume, if you have a cut and you're bleeding profusely, blood is leaving your body, obviously that's going to trigger your cortisol. Exercise will affect levels. And stress. If you've ever heard, that stress is not good for your body, stress will often, too much stress can lower your levels of cortisol, and then it actually causes your body to store the fat instead of release it. And here's just a picture, you can look at that. It's the negative feedback again. So pituitary gland is what is in control of it. ACTH is going to stimulate your adrenal cortex to release cortisol into the blood. Cortisol comes in, and that's going to stimulate glucose production. It's going to help promote fatty acid release and help break down sugars, fats, and actual proteins. And then sex hormones, you don't really think about these in your adrenal glands. Sex hormones are produced in the inner zone, mostly of the male type, can be converted into some female hormones in the skin and liver and such. And what happens is these hormones are going to supplement the hormones that are produced and released by the gonads. Some of your sex hormones, when you reach puberty, are probably stimulated by these sex hormones in your adrenal gland. Disorders, Addison disease. Anybody in here have? Okay, Addison disease, hyposecretion, too much adrenal hormones are produced. And Cushing syndrome is the opposite. Did I say that backwards? Did I say too much? I think I said that backwards. Addison, there's not enough of your adrenal hormones produced. Cushing's disease, there's too much produced. So those are two diseases that are affected by your adrenal glands. And there's the table, that's in your book, you can look at that. And the next one that we'll do is the pancreas. Insulin will be very important there.